So one thing PCB designers could keep in mind when they're designing their printed circuit boards is that inductance is the root of all evil. And so we want to minimize the plane inductance. And that means that we want to keep the dielectrics thin, we want to keep them close to the surface, we want to keep the width of the planes wider than they are long, and we can use higher Q dielectrics.
Designers should keep in mind that they're exploring new terrain when they're routing high-speed signals on flexible PCBs. And we highly recommend that they use simulation to avoid any surprises later on in the design process.
In your mind, you should do analysis first, and you should have a hypothesis to predict the result before you run the simulation.
Basically, what I would like to see more designers be more cognizant of is layer stack up. If you don't have the proper layer stack up and the dimensions, you may not have proper power distribution or optimal power distribution or impedance control.
And so I think that one thing that would be really beneficial for power supply engineers is if they learned a little bit more about the demands of the high-speed circuit and how it is that that influences the performance.
Signal integrity is mainly about three things, right? It's a loss. When your signal goes through a media, PCB, you get attenuated. Then the next thing important is reflection. You know, you're hitting, you try to reach from point A to point B. You want a signal goes, point B can receive it. But you don't want it all get reflected back. And the third one is noise, coupling. So it's about those three things.
And designers should always keep in mind of where are those return currents. Ground on a schematic is often neglected as a simple little symbol somewhere and left to the layout designer to figure out how they want to connect it. But you really do need to pay attention to how ground and those return currents are flowing.
SI interposers are, in terms of electrical characteristics, are very different from package and PCB. The universal design rule for the top layer of silicon interposer is really to minimize the trace length, because the SI interposer traces are very resistive, so you want to make sure that the traces are very short.
Let me tell you the best tip that I tell people for power integrity, and this is especially true in the automotive market. And what I tell them is that before they take their voltage regulator design and stick it on a 12 or 16 or in some cases 30 layer board, they really should build prototype level boards that are inexpensive, that allow them to characterize the parts that they intend to use and to resolve a lot of the design issues while it's still just a simple 2 or 4 layer board. They can do it relatively inexpensively and they're able to react to changes fast.